Today, I will be discussing with you about temperature and pressure controlling devices. Last class, I discussed about evaporator. In evaporator, having low pressure and low temperature, and in condenser, having high pressure and high temperature. So in refrigeration cycle, while working time, the pressure and temperature will be there. So we have to control the temperature and pressures while working the system. So this is a sketch of refrigeration cycle showing compressor, discharge line, condenser, liquid receiver, then expansion device, evaporator, then suction line. So in this, I am telling about condenser. Condenser having high pressure and high temperature. And here, evaporator having low pressure and low temperature. So while working time, we have to control the temperature and pressure. Okay, so when we get recorded temperature, then we have to stop the system. Like when temperature is increased, we have to start the system. For that purpose, a thermostat or temperature controlling device will be there. Like pressure, two type pressures in system, low pressure and high pressure. Evaporator side having low pressure and condenser having high pressure. Suppose in condenser the pressure is exceeding than the limit, then we have to control or stop the system. Like in evaporator, low pressure will be there. The low pressure is less than the limit. At that time, we have to control this system. For that purpose, controllers are required in refrigeration and air conditioning system. So two types initially with respect to the temperature control, and with respect to the pressure control. Like temperature control and pressure control required in system for controlling the system for smooth operations. So today we can go through temperature controlling and pressure controlling. In this, at the end of this section, you shall able to know what is temperature control, what is thermostat switch, what is pressure controlling device, what are the different controlling device and its construction and working. These are the topics to be covering today. First, we can go through temperature control. See, in refrigeration system, we need a recorded temperature. Example, air conditioning having high temperature. That means 22 to 26 degree temperature is maintaining. Then water cooler, bottle cooler, like that systems, 8 degree, 7 degree we are maintaining. Then refrigerators, like that system, -10, -12, -17. Freezers also -17. See, like these temperatures are maintaining in evaporator coil. Okay, so when particular temperature will reach, then no need of further working. If further is worked, the load will be increased. That means energy load or system load will be increased. That is no use in that system. So when a particular temperature is reached, at that time we can switch off the system with the help of a thermostat device. Okay, so temperature control is a device used to control the temperature while working of the system. For this purpose, we are using a thermostat, and this thermostat generally connected in series of the circuit This is the simple sketch of a thermostat. Then this is the internal diagram of a thermostat. This thermostat consists of a main body, outer having a main body. Then this part is known as thermal bulb or feeler bulb. Then having a capillary tube, this is a flexible tube, capillary tube, and this is bellow. And this system having thermal bulb, capillary tube, and bellow having volatile substance. Volatile substance means same refrigerant used in the system. Okay, and here one action is going. This bellow is expanding and contracting. That means when temperature increases, this thermal bulb is clamped to the last coil of the evaporator. So evaporator temperature is sensing in this thermal bulb. By that, inside of the volatile substance changing to liquid or vapor state. When vapor is coming, this bellow will expand. When it is liquid state, it will be contract. By expansion and contraction of the bellow, that means depends upon evaporator temperature. This bellow is increasing or decreasing, that means expanding or contracting. On that time, this contact point is closing or opening. Okay, so feeler bulb, capillary tube, bellow. Then next, a contact points. This is top is known as movable contact, and bottom is known as stationary or fixed contact points. And this set of contact points are connected in series of the compressor motor in small system. Then having a differential screw, here having a differential screw. Then below the bellow having a spring and having a adjusting screw. These are the main parts of a thermostat. Once again, I am repeating the main parts of thermal bulb, capillary tube, and bellow. And this is sometimes we are called power element. And this power element having volatile substance. Volatile substance means same refrigerant used in the system. Suppose our refrigerator refrigerant is R134A. If R134A is the refrigerant, here also in thermal bulb, capillary tube, and bellow having R134A refrigerant, that is known as volatile refrigerant. Suppose R600, our refrigerator is R600A is the refrigerant. So here thermal bulb, capillary tube, and bellow having R600. So same refrigerant, we are saying volatile substance. Okay. Then this contact points is connected in series of the compressor motor in small systems. In commercial system means air conditioned plant, like that system, cold storage plant. In that plant, these contact points are connected in series to the solenoid valve. There, a solenoid valve also there. That solenoid valve is fixed on the liquid line. Okay. So when the particular temperature, that means suppose minus 10 degree reached. So sufficient temperature is reached. We want to switch off the system. At that time, what happened? This will open and solenoid valve is disconnected and close the line. At that time, the suction pressure will reduce and low pressure cutout stop the compressor in commercial system. Okay, in commercial system, these contact points are connected in series of the solenoid valve. Okay, so when this contact point open, solenoid valve stop the liquid line. When solenoid valve stop the liquid line, what happened? The pressure reduced in the evaporator coil and low pressure cutout switch off the system. That is the working of commercial system. But in domestic system, directly cutting off the compressor motor. See, this is the sketch thermal bulb location. This is the thermostat, and thermostat having a capillary tube and a feeler bulb. This feeler bulb is clamped to the last coil of the evaporator, and electrical circuit is connected in series of the compressor motor. This is the connection. Okay, electrical connection, then feeler bulb connection. Feeler bulb will be clamped to the last coil of the evaporator. Okay, so here another 2 points also will be there: addition screw and differential screw. What is the function of addition screw? You know, in your house having refrigerator having inside a thermostat will be there. That thermostat we can operate by turning clockwise direction or anti-clockwise direction. Okay, if we fully turned anti-clockwise direction, it can off the system. Then while slowly turning clockwise direction, it can start the system, and when the rotation will be increasing, the temperature will be increased. When the rotation is decreasing, that means you can turn this knob clockwise or anti-clockwise direction. If you wish to increase the temperature, turn the adjusting knob or adjusting screw in clockwise direction. If you need to reduce the cooling temperature, turn the adjusting screw in anti-clockwise direction. Okay, so the function of adjusting screw is used to increase or decrease the cooling range. Okay, what is the function of adjusting screw? Is used to increase or decrease the cooling range. Then another is differential screw. Here one screw will be there. That screw is known as differential screw. The function of differential screw is used to increase or decrease the cut-in and cut-out temperature. Okay, so suppose cut-out temperature, a refrigerator cut-out temperature is minus 10 degree. Suppose and cut-in temperature is minus 5 degree. So minus 10 minus 5, that is the difference of the cut-in and cut-out. If you wish to increase or decrease this range, that means minus 10 change to minus 12, or minus 5 will change to minus 3. So now the change is there. Initially the range is minus 5 and minus 10. Minus 10 cut out and minus 5 minus 5 cut in. If you wish to change cut in and cut out, turn the differential screw in clockwise or anti-clockwise direction. Normally this is a company settings, a technicians or from our side, no need of any adjustment in differential screw, but you have to understand what is the function of differential screw. The function of differential screw is used to increase or decrease the difference between cut-in and cut-out temperature. So this is known as thermostat. So the function of thermostat is used to control the temperature of the refrigerated space. When the particular temperature is reached, it cut off, and temperature is increased and it will cut in. So in this way, the temperature is controlling. For that controlling, we use thermostat. Next, our topic is pressure controlling devices. So now temperature is controlled. Mainly the temperature is controlling in evaporator side. Next, pressure we can control. In refrigeration cycle, two pressures will be there. Low pressure will be there, high pressure will be there. While compressing, the high pressure is going to condenser, and while expanding, the low pressure is going to evaporator. So in our human body also, high pressure, low pressure will be there. Like that, refrigeration system also, two pressures will be there, low pressure and high pressure. So in our human body also, very strictly we are controlling the pressure. If pressure is low, that also very dangerous. If pressure is high, that also very dangerous for human beings. Like that, in refrigeration system, we have to control the pressure. So example, the high side pressure, 200 psi is the high side pressure. If it is exceeding than 200 psi, then it is overloaded and it is very dangerous to compressor motor, and other explosive or damage will be happen. So we have to control high pressure side. Like low pressure side, suppose low pressure side 40 psi is the low pressure side pressure setting. If that pressure is decreasing than that limit, at that time it will switch off it. Okay, so it does not, this pressure control device does not allow the system in overload conditions. Overload conditions means too high head pressure or too low back pressure. Back pressure means suction pressure. The pressure controlling devices are low pressure cutout. Simply we are telling LP cutout, high pressure cutout, HP here small mistake is happened, HP cutout, another is dual pressure cutout, and another is oil pressure cutout or oil safety switch. So these are the cutouts: low pressure cutout, high pressure cutout, HP cutout, dual pressure cutout, oil pressure cutout. Oil pressure cutout sometimes we are called oil safety switch. So first we can go for low pressure control system or low pressure cutout. This is the external view of a low pressure cutout. The function of low pressure control are used to control low side pressure of the refrigeration system. In low pressure side, I already explained 40 psi is a example. Suction pressure is 40. If 40 pressure is, we have to maintain. If the pressure is less than 40 psi, this switch will switch off the compressor motor. When the pressure come to normal, it will switch on the system. Why the pressure is decreasing? Suppose any block, okay, in reference cycle, any block is happened, the low pressure will be decreased. Another reason, if the gas is charged under, at that time low pressure will create. Then another is due to leakage. If gas is leaked, then sufficient pressure is not creating in low side. By these conditions, the low pressure cutout will switch off the system. That is the, when pressure will come to normal, that means 40 psi. When pressure is normal, it will be switch on the system. This is the internal diagram of a low pressure control switch. First, you identify the parts. What are the parts? First, a bellow, then having a spring, then having a adjusting screw. This is known as adjusting screw, and here having a differential screw like thermostat switch, like a adjusting screw and differential screw will be there, and a set of contact points. This is set of contact points, that is movable contact and a stationary contact. And here this bellow is connected to the suction line. I'll show you how it is connected. See, this is the cycle, this is compressor, and this is condenser, receiver, expansion valve, evaporator, suction line. See, in this suction line, the bellow is connected. Bellow is connected. And this is the contact point of the LP cutout that is connected to the motor circuit. So this bellow is connected to the low side. So I already explained our example 40 psi. When this 40 psi enter into the bellow, what happened? This bellow will have sufficient pressure and expand, and this contact point is closed and motor will run. Okay, so in normal condition, normal pressure, the contact point is closed and system will run. Any reason, that means now gas is leaked or blocked. By that reason, the pressure is reduced. That means the now pressure is 35 psi. Pressure is decreased. So at that time, the bellow pressure also reduced. This bellow will contract. At that time, this contact point moves up. Open the contact point. This contact point is open and stop the motor. So in this way, this switch on and off. When normal pressure is reached, it will close. When pressure is decreased than the limit, at that time it will be open and stop the system. This is the working of low pressure contact. Okay. And here also adjusting screw will be there and differential screw will be there. The function of adjusting screw is to increase or decrease the pressure range. Previously temperature range, here pressure range. We have to change the pressure range. For that, changing the pressure, turn the adjusting screw in clockwise or anti-clockwise direction. Next is differential screw. Here also cut in and cut out point. So cut in means 40 psi is the cut in. Cut out means 35 psi. If suppose the pressure is 35 psi, it will cut out. So here cut in and cut out range is 5 psi. If you wish to change, increase or decrease the cut in or cut out, that means instead of 35, change to 33. 40 will change to 42. So now range is increased. So if you want to difference, then you can change the differential screw. Normally from our technician side, no need of changing, already this company set up. So that is the function of differential screw. The function of differential screw is used to increase or decrease the difference between cut in and cut out point. Okay, so I'm simply shortening what is low pressure cutout. The function of low pressure cutout is used to stop the motor when suction pressure decreases than the limit, and start the motor when suction pressure will come to normal. Okay, in this way the low side pressure is controlling. Next we can go high side controlling. That is known as a high pressure cutout or high pressure control device. Okay, the function of high pressure cutout is stop the motor when discharge pressure increases above the limit. For example, 200 psi is our discharge pressure standard. So if the pressure is increasing than 200 psi, this switch will be open and stop the motor. In this way it is protecting, otherwise the pressure will be increasing and it tends to burst or motor will be burned. Okay, for that purpose we are using high pressure control device, and when pressure will come normal, then it will be start the system. How the pressure is increasing? Suppose you are charged over refrigerant. If you are charged over refrigerant, or condensation is reduced, or the line is blocked, on the way the line is blocked, by these reasons the pressure will be increased. Okay, so if there is no proper condensation, okay, or you are overcharged, or the line is blocked, by these reasons the pressure is increasing. If the pressure is increasing than the limit, our limit is 200 psi, that is today's our example. If this 200 psi is exceeding than the limit, what happened? This high pressure cutout stop the motor and protect the system. When the pressure come to normal, then what happened? It start the system. In this way it is controlling. So this is the simple internal sketch of high pressure cutout, and this is bellow, and this is a pivot and spring and adjustment screw, and this is contact points. See, here two figures will be there, and these contact points are connected in series of the compressor motor, and this bellow is connected to the discharge line of the system. Previously, the bellow is connected to the suction side. Here we are connecting, bellow is connected to the discharge line. So the discharge pressure is acting on the bellow. The bellow will expand. By expansion, then the limit, what happened? It will be open. This is open position. Left side showing open position. When the pressure is normal, the contact is closed. At that time, it will be run. Okay. So when pressure is exceed than the limit, the bellow pressure also expands. By that expansion, contact point open. This now it is open. Off switch. Okay, switch in off position. When pressure is normal, the contact point is closed and start the motor like it is controlling the high pressure cutout. So what is high pressure cutout? High pressure cutout is a pressure controlling device used to control the high side pressure of the system. When the pressure is exceeding than the limit, it stops the system. When pressure will come to normal, it start the system. In this way, it protects the system from high pressure. Next, we can go dual pressure control. Actually, dual means double. It is the combination of low pressure and high pressure switch. Okay. Previously, separate switch will be there. Low pressure switch separate, high pressure switch separate. Now, both the combination is coming. That is the low pressure dual pressure cutout, and generally only one set of electrical contact points are used in the control, although a separate bellow assembly is employed for each of two pressures. The low pressure and high pressure bellows of the control are connected with the low side and high side of the compressor respectively by means of copper tubing. The complete control is connected in series circuit with the motor. So here 2 points, 2 bellows. One bellow is connected to the suction line and another bellow is connected to the discharge line. Okay. Then contact points are connected in series of the compressor motor. See, this is the sketch. This is the dual pressure cutout. See, this is blue line. Blue line bellow. Bellow is connected to the suction line, and this is red line is connected to the discharge line. See both the pressure. So the discharge pressure is coming to the dual pressure cutout, and suction pressure also coming to the this cutout. By that action, this is the power in. By that action, the contact points will be open or closed. That I am showing now. So this is the internal diagram. This is LP cutout and this is a HP cutout. So in normal condition, both contact points are closed. Okay, in normal condition, these two contact, low pressure contact point and high pressure contact point. That means LP cutout and HP cutout. Both are closed position and motor will run. When suction pressure decreases than the limit, then what happens? This bellow will open and stop the motor. When suction pressure comes to normal, this will close and start the motor. Likewise, in high side, okay, when pressure is increases above the limit, it will expand and open the contact points and stop the motor. When it normal, it close the contact point and start the motor. In this way, it control the motor. So it is the combination of low pressure and high pressure sides controlling. So both bellow will be there, low pressure bellow and high pressure bellow, and two set contact points, low pressure contact points and high pressure contact points. In normal condition, both are closed and its system will run. In any reason, low pressure is decreases than the limit, or high pressure increases than above. At that time, contact points open and stop the motor. When low pressure is normal or high pressure is normal, the contact point is closed and start the motor. In this way, low side and high side pressure is controlled. Okay. Instead of LP cutout and HP cutout, we can use one cutout. That cutout is known as dual pressure cutout. That is the combination of low pressure and high pressure cutout. So now low side is controlled, high side is controlled. If two sides is controlled, another important is oil. Okay, oil pressure will be there. In compressor having oil, or when it is rotating time, the oil, sufficient oil is required and it creates a pressure. If any reasons the oil pressure is less, it does not allow the system to run. For that safety purpose, here one safety device or pressure controlling device is required. That is known as oil safety switch. So this is generally used with compressors incorporating oil pumps and on multi-compressor system. So multi, that means big compressors generally we are using oil safety switch. The function of control is to stop the compressor when oil pressure fails to reach a maximum safe level within a described period after starting. See, first the compressor will start. When compressor start, it reaches the sufficient oil pressure. If the oil pressure is not reached within the specific period means 2 to 3 minutes. Within 3 minutes, if the pressure is not reached, what happens? This switch will stop the compressor. That is the function of oil safety switch. Okay. So what is the function of oil safety switch? The function of oil safety switch is stop the compressor motor when the sufficient oil pressure is reached within a specific period, or while running time, if oil pressure is decreased than the limit, at that time it stop the motor. Okay. So this oil pressure as measured with a gauge is the sum of crankcase pressure, that means suction pressure, and pump pressure. So here two bellows will be there. See, top and bottom. Here one is oil pressure, bottom oil pressure is acting, and top low pressure is acting. Low pressure means the crankcase having suction pressure. That suction pressure is coming in this side, LP side, and a pump, oil pump having a pressure. That oil pump having a pressure, that pressure is acting on this oil bellow. Okay, since the oil pump function only when the compressor operates, the total pressure will be equal to the crankcase pressure during off cycle. That means when compressor start, the oil pressure rises to cut-in point of the switch. Anyway, we can see this picture. This is the internal diagram of oil pressure cutout. So two bellows. One bellow is connected to the crankcase. Already I explained by previous PPT. Okay, and below one bellow will be there. That is connected to the oil pump. So from oil pump, the oil pressure is coming here. From compressor, crankcase pressure is coming there. By that pressure, here one switch will be there. That switch name is known as differential pressure switch. The differential pressure switch initially is in closed condition. Okay, and here having a heater. This is known as which one? Heater. Okay, and this is known as time switch. This is known as time switch and a bimetal strip. Okay, and this heater is worked with the 240 voltage supply or 115 voltage supply. For that purpose, a resistance will be there. This is a resistor. Okay, if you wish to operate in 240 voltage, the supply is going this way. Okay, like this way it is going. Supply is going like this. Okay, if you wish to operate 115 voltage, you can give this line 115 voltage. So your heater is working with the one. So here a resistor. Okay, resistor will be there. Okay, and this is known as time switch. This is known as a time switch. This time switch means this switch will be 2 minutes to 3 minutes will be there. In normal condition or off condition, this contact is closed. This contact point is closed. Okay, and when now the compressor is start, the oil pressure reaches to cutting point of the switch. Okay, so now it is started. By that started, the differential switch will be open and break the circuit to the heater, and the compressor will operate normally. Okay, that means when sufficient pressure will reach, what happened? This contact point, differential switch contact point is closed. Okay, and what happened? The supply is going to this heater, and this heater is heat. While heating this heater, what happened? This contact points will be open. Okay, so the different switch will be open. So switch will be open and break this circuit of the heater. So this heater is opened. Now heater is opened. This heat circuit will be the different switch will open and break the circuit to the compressor, and compressor will operate normally. If the usual pressure does not rise to cut-in point within the limit, that means 60 to 180 seconds, that means up to 3 minutes, the different switch contact will not open and heater stay in circuit. Okay, so if pressure is not reached, okay, what happened? The supply is going to this point and heater is heating. Okay, and this will open. And this causes a bimetal strip in the timing relay to wrap and open the timing contact, will break the circuit to the starter coil and stop the motor. So in this way, the motor is stopped. Similarly, if the usual pressure falls below the cut-in point during operation, the different switch will close and energize the heater. Okay, so after 1 hour, the oil, due to any reason, the oil pressure is reduced. See, oil pressure falls below cutting point. At that time, what happened? This will be closed. Okay, when this is closed, the heater will be heating. By that heating, this strip will be open. When strip is open, what happened? The supply is going to the compressor is open and stop the motor. Okay, so this function of the switch is, if pressure is normal, that means oil pressure is normal, it allowed to run the compressor motor. Due to any reason, initially or after running the compressor, if sufficient oil pressure is not reached in a particular level, this switch does not allow to run the system. Initially, it allowed to run up to 3 minutes. After 3 minutes, it does not allow to run the system, or after some time while working, oil is leaked or any reasons, the oil is reduced. Then what happened? This heater will be heat and disconnect the connection of the compressor motor. In this way, it controls the oil pressure in the compressor. Okay, so what is the function of oil safety switch? The function of oil safety switch is to allow to run when sufficient oil pressure in the system. And if there is no sufficient oil pressure in the system, it does not allow the system to run the compressor. So it has two bellows. One bellow is connected to the crankcase and another bellow is connected to the oil pump. With the difference of that pressures, it is working. And in addition to this, some heater also will be there to maintaining the time delay. By that, this switch is working. This is this symbol, a circuit of a motor. This circuit showing a solenoid valve, thermostat, low pressure cutout, high pressure cutout, oil pressure cutout. I already told these cutouts are almost all are connected in series of the circuit. If any one is open, the current is not reached to the motor and motor will be tripped. By that interlocking, these are the arrangements. So these switches are connected in series of the motor. So LP cutout, HP cutout, oil pressure cutout, thermostat and solenoid valve, these are all connected in series of the circuit. Any one is open, the motor is stopped. When all contacts are closed, then it will be run. Then pressure controlling is over. Low pressure is over, high pressure is over, temperature controlling also over, then oil pressure controlling also we are maintained. Then we can see some safety devices in our refrigeration system. Some other safety devices are safety device. What is safety device? Safety device are used in refrigeration and air conditioning system for the safety of the system. Compressor is driven by an electric motor. The compressor is operated by an electric motor. Sometime due to any fault, the pressure of the gas rises above the dangerous limit in the machine, which causes to burn the motor, or any overload conditions. It does not allow to run the motor. For that purpose, we need safety devices. See, actually, the cutouts, low pressure cutout, high pressure cutout, HP cutout here, dual pressure cutout, that is a pressure controlling, as well as it is a safety device also. Now new safety device we can go through now: pressure relief valve, fusible plug, water failure switch and overload protector. Okay, another safety device are, what are the other safety devices? Pressure relief valve, fusible plug, water failure switch and overload protector, OLP. This is a pressure relief valve, very simple. Okay. Pressure relief valve are used to release the excess pressure when developed in the closed system. In one closed system, if pressure is exceed and the limit, it is open. See this figure, 2%. This is closed. So this is inlet pressure and this is outlet. Now it is closed with the help of a disc and spring-loaded disc. And this is located on discharge line or condenser head or liquid receiver. So that pressure is acting here. If normal pressure, the spring-loaded disc will be closed. If pressure is exceeded than the limit, what happened? The spring-loaded disc will contract and this will open and excess pressure go outside or taken back to suction side. Okay, this is the opening and closing of pressure relief valve. Okay, here a spring loaded disc. With the help of spring loaded disc, it is controlling. When pressure is increasing than the limit, the spring will contract and disc moves upwards and open the valve and excess pressure go outside or taken to the suction side to prevent the loss of gas. This is the working of pressure relief valve. Generally, it is located on discharge line or condenser, water cooled condenser head or liquor receiver head. Next is fusible plug. See, we know in our home fuse will be there. Suppose excess current is coming, the fuse is burned. Once it is burned, we have to reconnect it. Like here in our refrigeration system, fusible plug will be there. See, this is the sketch of fusible plug, and this is fixed on the head of the compressor or liquor receiver head or condenser head. In that areas we are using. See, having a material. This is a light alloy material. Okay, and this is a threaded portion. It is fixed on the head of the compressor or liquor receiver head or condenser head. When pressure increases, temperature also increases. That's our rule. When pressure increases, which also increases simultaneously, temperature also increases. At that time, this metal is melted. Once this metal is melted, what happened? The gas go outside. In this way, it protects the system. See, this is the internal sketch. Fusible alloy. This is the fusible alloy. Okay. Through this fusible alloy will be melted. When it is melt, what happened? The gas will go outside. In this way, it protects the system. So this is a fusible plug. So fusible plug relief valve is pipe threaded to connect it to the equipment. Due to high temperature, the alloy in the plug melt, thereby releasing the pressure. In this way, the pressure is released. A simple law: when temperature increasing, pressure also increasing. By that, this metal is melting and gas is going outside. Okay. Another is water failure switch. This is a safety device. That means this is connected in water cooled condenser and connected in series of the compressor motor. It breaks the electrical circuit of compressor motor when there is restriction in the flow of condenser water in water cooled condenser by any reasons. That means water cooled condenser required water, and that pressure is acting on the bellow, and contact points are connected in series of the compressor motor in water failure switch. Due to any reason, water is reduced in water cooled condenser. This failure switch, the pressure will be reduced. When pressure is reduced, the bellow will contract, open the contact points and off the. This water failure switch is working similar to LP cutout. Simply we can tell this water failure switch is working similar to LP cutout. When LP cutout pressure is reduced, it will off the system. Like that, here also bellow will be there. In the system also, one bellow will be there. In that bellow having water pressure. Water pressure is normal or decreasing. Okay, when decreasing, bellow will contract, contact points open and motor will off. Like that way, protect the motor. Otherwise, what happened? The condenser pressure is increasing, then the pressure is increasing. By that, high pressure cutout will be cut out. Okay. So this is another safety device. Water failure switch. The function of water failure switch is to stop the motor when water pressure is reduces in the water cooled condenser. When pressure is normal, water pressure normal, the switch will on the system. Another one device will be there, water regulating valve. Water regulating valve. See, in our house also gas stove will be there. by that gas stove, by turning the knob, you can regulate the flame in a higher flame or lower flame by turning your regulator. Like that, here one water regulator will be there. Automatically, the water is adding more to condenser or less to condenser according to condensation of the condenser. Okay, this valve is used to regulate the flow of water to the condenser in such a manner that discharge pressure of the compressor is limited to the designed value. This regulator is responds to the changes in temperature and pressure of the water supply and to changes in the rate of reference to the condenser. This is a simple sketch, picture little bit shade. So top here condenser pressure we are giving top and having a bellows spring and center having a stem. Okay, so when condenser pressure is coming, the stem moves downwards or upwards due to condenser pressure, and here water is going. So when condensation increases, what happens? The pressure also more. This stem moves downwards and more water is supplying to the condenser. When condenser pressure decreases and this bellow pressure decreasing, stem moves upwards and reduce the orifice and reduce the flow into the condenser. That means automatic expansion valve. The example is for this, a good example is automatic expansion valve. In automatic expansion valve, with respect to the pressure, what happened? The flow is controlling. Like that, here condenser pressure is acting on the top. By that, condenser pressure two type will be more condensation, less condensation. Okay, more condensation, less condensation. Right at that time, the water will supply more or less. Due to condensation, the pressure is acting on the bellow. The bellow is increasing or decreasing. That means expanding or contracting. On that base, this stem moves downwards or upwards. By that, flow also will be controlled. Known as water regulating valve.
Sir.
Okay. Last.
Sir.
Last.
5 more. Yeah,
okay.
5 minutes.
Okay. So some controls were learned. I hope you have to understand. If you have any doubt, you can contact me. Okay, I will be available. If you have any doubts regarding in this topic, you can freely contact me. Okay, I will clarify you. You can call me by this number. If you have any doubt, I will clearly explain with you. Definitely, I will be available next 1 hour waiting your calls. Okay. Thank you.